You type a simple instruction into an AI chat box. The result comes back completely broken. It is messy, poorly formatted, and entirely confusing. Your first instinct is probably to blame the machine. Beat. But here's the hard truth we have to face. The machine is not wrong.
Yeah, we inherently want to blame the tools we use, right? But software simply cannot fix a fundamentally vague business process.
Exactly. Bad AI results almost always come from vague human instructions rather than broken technology.
Right.
So, if the core problem is human clarity, we first have to understand what the machine actually needs from us.
Whee! Welcome to today's deep dive. We are unpacking a massive shift happening right now. We're moving away from writing simple text prompts, and we're stepping into a world of building reliable, autonomous workflows.
And this requires a fundamental rewiring of how we think about work. We are deeply conditioned to micromanage our technology.
We really are. So today we will cover what autonomous agents actually are, the AR framework for when to use them, and how they adapt when workflows break.
We will also get into the 4 internal roles that make them tick, and why fixing your own messy instructions is the only way to survive the future of work.
It is going to be a fascinating breakdown.
Yeah, so to give better instructions, we need to fully grasp the systems we are instructing. We have to understand the architecture under the hood.
Let's start by looking at how these new autonomous agents differ from the standard chatbots we've been using.
Well, standard chatbots operate on a very strict 1-to-1 ratio. You provide one input, and it generates one output. They basically just sit there in waiting mode.
Right. Unless you explicitly prompt them, they take absolutely zero initiative.
Yeah, they are entirely reactive. Autonomous agents operate on a completely different paradigm. They do not require you to hold their hand through every micro step. You essentially just hand them a final goal. They process the environment, make independent decisions, and find the logical path. They finish the job without you constantly hovering over them.
They figure out the messy middle steps on their own. Exactly. Think of a normal chatbot as a student driver. You have to instruct their every single mechanical move.
Like put your foot on the brake, check the blind spot, turn the wheel.
Right. You are constantly managing their immediate reality. An autonomous agent is much more like a professional hired driver.
You just hand them the address of the final destination.
Yeah. You sit back in the passenger seat and let them work. They handle the unexpected traffic jams. They navigate the detours safely without asking for your permission at every intersection.
So, if it is a professional driver, how does it know the rules of the road without me telling it every single time?
Good question. The agent relies on its core programming and the strict guardrails you establish initially. It uses internal logic to break your massive goal into smaller executable actions. Then it constantly checks its own progress against the overarching rules you defined at the very beginning of the process.
Got it. You set the destination up front, then step completely back.
Exactly. Letting the machine shoulder the heavy cognitive lifting is the entire point.
Now that we know we can safely hand over the steering wheel, we face a new problem. How do we objectively decide which trips the agent should drive?
We can apply a very effective mental model here. It is widely known as the ARR framework.
That acronym stands for Autonomous, Recurring, and Reviewable. Let's explore the mechanics of those 3 pillars.
Yeah, so the first pillar is autonomous. This simply means the rules of the task can be defined clearly from the start.
Right.
The system has all the necessary permissions to run completely alone.
It never hits a wall where it suddenly needs a human password or emotional decision. Beat. Let's unpack the recurring aspect next.
Recurring means the task happens on a predictable cycle. It might be a daily data pull or a weekly summary.
Yeah, setting up an agent requires a heavy initial cognitive load.
Exactly, so you would never build a complex autonomous workflow for a random task you only perform once a year.
The return on investment for automating a yearly task is practically zero. Finally, we have the reviewable pillar.
This might be the most critical piece of the puzzle. There must be a crystal clear way to verify the output. You need an objective standard to quickly see if the machine's final result is flawless or fundamentally flawed.
If a process fits those 3 criteria, it is a prime candidate for an agent. But some functions must always stay firmly in human hands.
Absolutely. We should never try to automate the entirety of a business. Deeply complex human emotions cannot be mapped into software.
Careful, nuanced human judgment must remain with you.
Yeah, and highly rare or historically unprecedented tasks should also remain manual to ensure safety. For instance, you should never deploy an agent to handle sensitive customer phone calls.
Right. When a client is genuinely upset, they require true empathy. Creative brainstorming sessions also demand our unique, messy human intuition.
Right, and those specific moments require intuitive leaps that logical machines simply cannot replicate yet.
Could I use ARR to let an agent handle my sensitive client negotiations?
Oh, never. Negotiations require reading the subtle temperature of a room. They involve deep psychological judgment and strategic empathy.
Yeah. An autonomous agent cannot interpret the complex emotional state of a frustrated client.
Makes sense. Yes to recurring data, no to emotional human judgment.
Right. Protecting the human element is what makes the automation actually valuable.
Let's challenge this idea a bit. If a task actually fits the ARR framework perfectly, why not just use standard automation? I mean, we already have tools for that.
We certainly do. Traditional platforms like NAN or Zapier are incredibly popular for a reason. But those fixed workflows are actually quite fragile under pressure.
They follow a rigid, pre-planned track like a freight train.
Exactly. If a software bridge or an API returns an unexpected error, the traditional workflow completely crashes. 2-sec silence. An API is a software bridge letting two programs talk directly.
And if that bridge collapses, a traditional workflow comes to a screeching halt.
Yeah, it throws a fatal error message and shuts down entirely. It possesses zero ability to think outside of its hard-coded box. Autonomous agents handle these unexpected roadblocks in a completely different way.
Right. They utilize an architecture known as a smart loop. They dynamically assess the reality of the situation in real time.
So they recognize that the software bridge is broken.
Yeah, but they do not just panic and shut down. They formulate a new plan and adapt to the obstacle naturally. If one specific digital tool fails, they automatically retry the action. Or they dynamically search for an alternative tool to complete the mission.
What exactly triggers that smart loop when an unexpected error happens?
The system attempts an action and receives a failed error code instead of the expected data payload.
Right.
That unexpected signal forces the agent to pause its current track. It evaluates the specific failure reason and immediately calculates an alternative route to reach the final goal.
The error itself acts as the trigger to find a new path.
Exactly. Resilience is baked directly into the foundational logic of the system.
So what is practically happening inside that smart loop? How does it manage to stay so incredibly resilient?
Well, from an outside perspective, it looks somewhat like magic. But under the hood, it is highly structured and profoundly logical. There are 4 distinct internal roles working together.
They operate in a continuous collaborative cycle. Let's break those 4 roles down for the listener.
Sure. The first role is the analyst. It surveys the raw, messy data landscape first. It searches for hidden statistical patterns that human eyes typically overlook.
It brings order to the initial chaos. Then it hands the baton to the planner.
Right. The planner is the strategic mind. It decides the exact sequence of events required next. It constructs a clear, step-by-step logical plan based entirely on the analyst's initial findings.
Then the system hands that blueprint over to the operator.
Yeah, and the operator is the hands-on worker. It executes the real-world action. It physically writes the required text. It formats and sends the emails. It pushes updates directly to your databases or your GitHub. GitHub is a platform where developers store and share code.
The operator brings the theoretical plan into reality. Finally, we have the auditor.
Yes, the auditor serves as the uncompromising quality control check. It meticulously reviews the operator's output, searching for any logical inconsistencies.
Right.
It hunts for missing variables or hallucinations before presenting the final result to you.
Let's use a tangible, real-world example to ground this concept. Amazon Web Services utilizes systems they call frontier agents.
The architecture behind those systems is genuinely fascinating. AWS security agents and DevOps agents operate completely autonomously. They run silently in the background for hours or even days at a time.
They independently investigate why complex server errors happen. They deploy fixes to critical cloud operations without a single human clicking a button. 2-sec silence. Whoa! Imagine scaling to a system that fixes cloud outages while you sleep.
It sounds like science fiction, but it is happening today. They analyze a server spike, plan a load balancing fix, and deploy the code.
Yeah.
All of this occurs while the human engineering team is sound asleep.
Do these 4 roles actually pass the work back and forth until it is perfect? I mean, could they just get stuck in an infinite loop if the auditor keeps rejecting?
They do pass it back and forth continuously. If the auditor spots a flaw, it rejects the operator's work immediately. It sends the task back to the analyst or planner with specific feedback.
Right, but what about the infinite loop?
Well, to prevent an infinite loop, they are programmed with strict execution limits. The cycle repeats until the goal is met or the maximum attempt threshold is reached.
Incredible. It is an automated teamwork cycle until the exact goal is met.
Yeah, that relentless internal debate is exactly why the final results are so reliable.
Let's take a quick break right here. Sponsor. So before the break, we explored how Amazon Web Services runs autonomous agents flawlessly for days at a time. So why do everyday users constantly struggle to get an agent to execute basic office tasks?
The harsh reality is that autonomous agents strictly amplify weak processes. You cannot throw sophisticated software at a vague, undocumented business model and expect a miracle.
The technology essentially acts as a mirror. It boldly reflects your own lack of operational clarity.
Yeah, and we fall into this trap constantly. Let's examine the vague instruction trap. Imagine sitting down and typing this prompt. Read my emails and send replies to the important ones.
To a human assistant, that sounds perfectly reasonable.
Exactly, because a human assistant shares your cultural context. But to a machine, it is an absolute nightmare of ambiguity.
Right. What does the word important actually mean in mathematical terms? Beat.
Machines do not possess subjective values. A properly designed security-first agent will outright refuse to execute this prompt.
It recognizes that subjective human judgment belongs exclusively to humans.
Yeah, and if a less secure system is forced to execute that prompt, it will just guess, and probabilistically it will guess wrong, creating a massive headache.
Beat. I still wrestle with writing messy, vague instructions myself when I'm rushing.
Oh, we all default to that behavior. The chat interface mimics human texting, so we unconsciously treat the machine like a human mind reader.
There is a highly effective rule to fix this instinct. It is referred to as addition by subtraction.
This is arguably the most powerful prompt engineering technique available. Ruthlessly removing unnecessary text improves AI performance almost immediately. In this context, less is demonstrably more.
Let's share the exact testing scenario from the research to illustrate this. You instruct an AI model to write 5 email subject lines.
Right. But you apply a very strict mechanical constraint. You demand a hard limit of exactly 33 characters per subject line.
When people write that prompt, they usually add polite conversational filler. But using addition by subtraction, you strip all of that away. You append the prompt with, don't explain, don't say hello.
You eliminate all the conversational fluff that dilutes the core instruction. The resulting output is 100% clean.
You receive exactly what you requested with 0 extra text requiring manual deletion.
Exactly.
Why does giving the machine fewer words actually make it perform better?
Well, it comes down to how language models process information. Every extra word you type introduces a new mathematical variable. The AI's attention mechanism tries to assign weight to every single word you provide.
Right.
So when you eliminate polite filler, it focuses all of its processing power purely on your strict parameters.
Fewer words mean a much smaller chance for the machine to get confused.
Keep your instructions incredibly simple. Keep your constraints ruthlessly strict.
This inevitably brings us to a much broader, massive question. If removing human vagueness is the ultimate key, what happens to the human?
Yeah.
If basic digital tasks are seamlessly handed over to these systems, where does that leave human knowledge workers?
The fundamental nature of the workplace is going to change completely. We have to face this reality with open eyes. Basic digital output is rapidly becoming essentially free.
Anyone with a keyboard can generate functioning code in a matter of seconds. Anyone can spin up thousands of words of coherent text instantly.
Because of this sudden, massive abundance of basic output, deep human judgment becomes exponentially more valuable. 2-sec silence. Possessing refined taste is shifting into a rare, highly compensated skill.
It becomes about knowing what is genuinely exceptional versus what is merely mathematically average.
Exactly. Junior roles that rely entirely on summarizing basic information will decrease. Those simple, highly repetitive tasks are being handed to the machines.
But this technological shift simultaneously creates incredible new career trajectories.
The autonomous machine is not going to replace you. However, a human who understands how to orchestrate that machine certainly will. Professionals who can architect, repair, and train these complex systems are going to thrive.
To stay ahead of this curve, you must actively practice every single day. You cannot merely read theoretical articles about this technology.
Yeah, you have to get into the trenches. Start setting up small, localized systems to solve your own tedious workflow problems today.
If basic output is essentially free now, how do I actually build that valuable taste?
Taste is forged through relentless, constant iteration. You must review hundreds of varied AI outputs, identify the subtle flaws, and ruthlessly adjust your constraints. Over time, you develop a deep intuition for what high quality actually looks like, and you learn exactly how to demand it from the machine.
Right. Taste comes from daily hands-on practice, not just reading the theory.
You essentially have to evolve from being the writer to becoming the strict, demanding editor.
Let's synthesize this entire deep dive into one grounding concept: heat. The fundamental dividing line between a successful autonomous workflow and a complete disaster is not the underlying technology.
Right.
It is entirely about human clarity.
The machine is just a highly efficient engine. You still have to lay down the tracks perfectly.
The burden of execution belongs entirely to the machine now, but the heavy burden of judgment, constraints, and standard setting will always belong to you.
You must become the visionary architect. The agent is simply the tireless builder executing your exact blueprints.
Before we wrap up today, we want to leave you with a provocative thought to mull over. Take a hard look at the recurring tasks you completed this past week. 2-sec silence. How many of those tasks actually required your deep, unique human judgment? And how many were you just acting like a human API, mindlessly moving data from one box to another?
It is a deeply confronting question for any modern knowledge worker to ask themselves.
Thank you for taking this deep dive with us. We highly encourage you to test the addition by subtraction rule in your own prompts today. See the remarkable difference in clarity for yourself. Out to your own music.